Good morning or afternoon, everybody. Hey, I just wanted to give everyone a resource for the activity that we're going to be working on today without me. I did want to remind everyone that the work I give when a substitute is here needs to be completed uh, with that substitute. So when I get back, I will be checking and collecting all of the work, and any work that is not done will receive a 0 with no chance to complete it later. So yeah, when the sub is here, work must be completed. All right, so talking about this, we're going to be talking about our parts of the experiment. And in several classes, we talked almost about everything, but I'm not sure we talked about every single thing in any class. So yeah, well, let's hit these. So yesterday we were talking about our titles and hypotheses, and both of those things included you all identifying our independent and dependent variables. With our independent variable being the variable controlled by the experimenter, and our dependent variable changing as a result of the independent variable. Okay, and sometimes we're really just calling these things the results. So in a lab, when you collect data, you're collecting data on our dependent variable. So I, the experimenter, change something, and I see a change happen as a result. So with our Dino Nug example, right, I give my son more Dino Nugs, and I notice that he has less temper tantrums, something like that. Okay. Now, if I really want to know what is in charge of this dependent variable, I need to make sure that I'm being careful and only changing one thing at a time. If I change multiple things at a time, I wind up not actually knowing what is in charge. All those things that we want to have not changing are going to be called constants. So things that stay the same between trials. Okay? And that's why so many experiments are done in labs and air tunnels and things like this. We're trying to cut down on environmental changes that might kind of get in the way of us really understanding what is literally changing our dependent variable. On top of that, if we are going to actually draw a conclusion, we need to be comparing a couple different trials. The experimental group is often what we think of as the experiment. So this is the group where we change. So the group with a change to the independent variable. So let's say I come out with a medicine, and this medicine is supposed to be able to help people with some pain. So I find a group of people in pain, and I give them the medicine, and I measure how it affects their pain. So again, my independent variable would be having medicine, and my dependent variable would be how it affects their pain. And if I give them medicine, and let's say 70% of them feel better, that would be fantastic. And people want to jump to the conclusion that this medicine must work. But that's not necessarily the case, because we also have to have this experiment happening with a control group. And this control group would be the group not experiencing the change to the independent variable. So what would that look like in our medicine example? I'd probably give these people a placebo, okay? And a placebo is going to be like a false treatment given to the control group The reason we do this is this thing called the placebo effect, where somebody is given medicine and they think, oh, I'm given medicine, I must feel better. So if I give the control group this medicine and 70% of them feel better, that tells me that maybe the experimental group, the change was not because of the medicine, but it was because of this placebo effect that's happening to people. So you really are unable to draw a conclusion in an experiment unless you're comparing the experimental group to the control group. And a significant result could be less exciting than it seems. Like if I give that same medicine to my experimental group, and this time let's say only 30% feels better, that feels disappointing, right? 30%, that's not a huge number. But I give the placebo to the control group, and let's say only 5% of them feel better. Is 30% significantly different than 5%? I would say so. So in that case, even though the number is very low, this is probably a successful drug. It's not unusual for drugs to only be effective at, 15, 20, 30% of the population. Okay, so yeah, as long as it is significantly different than the control group, then this experimental group is probably actually experiencing a meaningful change, and that is how you draw your conclusion. Okay, again, it's very tempting to run an experiment with only a experimental group, but if we're unable to compare it to a control, we're not going to have a very meaningful result. All right, thank you, everybody. Please email me if you have any questions, but I have confidence that you'll be able to get this work done. Have a wonderful weekend. Thank you.